Hi, my name is Will Summers, and in the third lab, Black Hole Orbit, we are given the challenge of calculating the unknown mass of a black hole. Now, a black hole is a substantially small object with a large mass that creates a large gravitational field upon other objects. In this case, we are given the star with many positions in order to calculate the mass. So, from the star, we're given a set of data points for the star's position. And by using the momentum principle, we're able to calculate the final mass of that black hole. Now, here, I would like to show you a little bit of a screenshot of the star's data. Like I said before, the coordinate positions give us insight into the star's velocity and the forces acting on us. And this leads us to discovering the mass of the black hole. And as we move on, the equations that we use were F net times delta t equals change of momentum, along with F net equals delta p over delta t, which, as you can see, are the same thing, just changed a little bit. And we must also know that we must break the force and momentum to parallel and perpendicular components to give us a more accurate display of the force acting upon it. Continuing on, by importing the star data into our Python file, and also including the object representation of the black hole and the sun, along with properties of the star, including the mass, which is 1.989 e to 30, along with the black hole position, and constants such as the gravitational constant, 6.67 times e to negative 11, we're able to calculate the position of the star over time, which would give us the mass. Likewise, we also include the velocity and momentum, both of which are given in the initial and final forms, because we need to find the change of momentum, which we are also given later for the change of velocity is v final minus the initial, and the change of momentum is p final minus p initial. And next, we move on to a big portion of our while loop, which is the change of momentum over change of time. Here we input several equations, such as the perpendicular and parallel components of the force and momentum. And finally, we represent these forces by arrows correlating to the direction and magnitude of the force. And now we're given a screenshot of our recording, which in the center we have our black hole, and off to the left we could see our star at a certain position. Here we get a look of the object's overall motion along with the arrows corresponding to the forces at play. We have the perpendicular one, as well as which always is perpendicular to the motion, the parallel one, which is parallel to the motion, and finally gravity, which is always towards the center. Now we'll take a look at our Python code and the actual module as it moves around itself. We can see it coming around. We have the forces at play, the gravity always pointing at the black hole, perpendicular to the motion, and parallel to the motion. And we see that the parallel component in this case is opposite as it was at the beginning, because that is the direction of our new gravity. Finally, the output from our model, we are able to get the mass of a black hole. For my specific case, that mass was found to be 3.98 e to the 31 kilograms, a very massive amount. And finally, moving along, we asked our questions. What does it mean in respect to why the force is not the same thing as the change of momentum? Here we know that the momentum is a product of mass and velocity. And with a constant mass, the dp over dt refers to the change in speed over time. However, a force is a push or pull that is used to change an object's momentum rather than measure it. So we can see our change there. And finally, our what if question. What would happen if, instead of our old black hole, we replace it with a new one, and we're only given its gravitational constant and its location. Would we be able to find the mass in that new black hole? Well, the answer is yes. If we were to place it uh, and had the gravitational force along its positions and change the star's momentum and the forces acting on it, we could find the mass just as we did in this lab. And finally, in conclusion, we can see that by giving uh, star position points, we're able to find change momentum, the force, and finally the direction and mass of a black hole that is acting upon it.